Along with making all the hold downs and straps and cleats and such that hold this together, I'm going to have to make the nuts that tie off all the rods and cleats for the axles. Chose to make these 540. That is a 125 diameter, about a 3 millimeter thread on these. And this picture shows them to be 8-sided. I would think, and I may be wrong, that the period correct would be 4-sided. But since I don't have a 4-sided nut driver and I want to put these together relatively easily, I'm going to make them 6-sided. And since there's at least 8 of them here, and I know there'll be more in upcoming models, I decided to run them on the CNC. Threaded little slugs, I just put them in there and run the hex with the CNC, and I go around twice to remove any trailing edge burrs. Let's take a look at how that's done. It is a 22-second process to make a hex nut. It's the beauty of CNC.
Before heading over to the CNC, the hex nuts will start off as blanks that are drilled and tapped. And they're drilled and tapped long enough and deep enough that I can get multiple nuts out of each one of these blanks. There is a stop inside this collet, so the depth of the drilling and the depth of the tapping should remain the same. I always tap it a little bit deeper than I need it. That way there's guide threads for the next nut in line after I part these off and put them in the CNC. I ultimately changed over from the 3-flute coated Amugi tap that I'm using here to a 2-flute high-speed tap. 2-flute taps just work a whole lot better in brass and aluminum and gummy materials that tend to stick. This coating is more for steel than for non-ferrous metals. As I mentioned previously, I will go around this hex profile twice to eliminate any trailing edge burrs and save myself a little bit of bench work. This is now a double-ended blank, and we'll go over to the lathe for parting off and chamfering.
The arbor that I will be using to do the back of these flange nuts is just a piece of brass with a thread all the way through. If your tap isn't long enough, then by all means relieve some of the leading edge of the collar with a bigger drill and only tap the very end. I'm going to screw these guys on there backwards, like so, and face them off in a collet using a stop that will register against the screw head. Let's do it.
This shot right here is a perfect example of why you don't use a thread as a locator. For facing it's okay, but for turning operations you can never trust the thread for concentricity. I think it's plenty clear to see why I chose to do this on the CNC. Spin indexer would have been fine, but boy, you'd be losing your mind when you were done.
Hey guys, a little side note here. When you have a bunch of small pieces, when I have a bunch of small pieces, I like to keep them contained, and on the off chance that they drop out of your hand, hit the floor, whatever, that they don't all just go in different directions. This is aluminum wire, and I don't know what you guys use, but I use suspended ceiling hanger kit. It's a 24 pieces of this aluminum wire, about 2 feet long, available at your local home center, and I use this wire for everything. It's real handy to have around. I got a pack hanging on the side of my toolbox. Consider picking a pack up next time you're at Home Depot or Lowe's or whatever home center is close to you. Suspended ceiling wire hanger set. This is the stuff that's up above the drop ceilings in your office and such like that. Love it.
Next parts I plan to address are the strap bolts that hold the trunnion strap down. That'll be these guys here, lighting up in red. And these little pull bolts, I guess they are in the back. Got the carriage all ghosted out, semi-transparent, so you can see exactly what they do. They go all the way through and secure the axle to the chassis. Let's get out to the lathe, and I'm going to start with these guys in the front first, right here. If you ever push a piece of round stock across the bandsaw by hand, vertical bandsaw, it's a really good idea to invert a vise like this to secure it and keep it from rolling and pinching your fingers. That is a huge wake-up call when it happens. Be very careful and use this technique. Because I'm going to be using this stock for extended small diameter turning, I just want to make sure that it is straight to start with and not bowed excessively. In order to keep the workpiece as rigid as possible for the threading operation, I am only going to turn a required diameter and a required distance on this for the thread initially. I'm going to do this to both ends of that blank. I'll thread it, and then I will continue on with the long diameter relief required. If you have followed this channel for a while, you know that I do most of my threading with my tool inverted. And if you try to invert a tool and lock it in your tool holder, you're going to find out that you've run out of height adjustment with the thumb wheel on the tool holder. And it's bottomed out and it's not going to go any further. Let me show you my solution to that. Keep in mind that if you do make an adapter for your tool holder, that you're going to use it for turning and boring, so it should be reversible. This is a little piece of aluminum and it's nothing fancy. The center cutout clears the stem for the adjuster nut, and the other cutouts are so you can get the tool in and out. In this profile right here, it would be used like this for a boring operation. So disregard where the tool is. It would be facing in that direction. And make sure that when you put your adjustment screw in, that it's hitting a solid part of the block. There's two areas on the Aloris tool post that you want to register against. Either one of them is fine. Anywhere in there is fine. Nothing precision about this block whatsoever. And you can see that as the screw progresses down past that surface, the tool height would go up. This works really well, and if you haven't made one, you should make one. It's a lot of benefit in having one of these in your box. And for the threading operation, the tool in this particular presentation, all you need to do is take that screw out, reverse the block, put the screw in from the top, secure it, and away you go. To keep everything rigid and reliable and repeatable, make sure that you tighten down the thumb wheel on the tool holder to secure the adapter in place. Off you go. As I mentioned previously, the adjuster screw needs to hit a solid section of the block there or there. Don't let it hit on the wedge, because the wedge will change the height depending on how wide the dovetail is on the tool holder. As I advance the material out of the collet, I am looking at the last diameter that I turned for concentricity. That is more important than anything else. If the material does start to bow, at least you want where the extensions blend to blend cleanly. You can always straighten it after the fact if you have to. And a single cut on something like this is definitely the way to go. If you take a look at the end where the thread is, you can see that the material, the stress in the material is starting to move this particular turning. The blends are clean, and I will bump that with a hammer when I'm done to bring that back in. That is easily corrected. This extension here is about 52 millimeters, about 2.125 inches long. It's a good idea to turn the machine off to locate the tool for the final overall length pass, because the stem is so fragile. If you were to touch the face of this part with that tool, it would probably climb up and over the tool immediately and just ruin the part. So shut it down, locate it with a loop, locate it with a feeler gauge, whatever you need to do. And here comes the hammer work. Watch the end where the thread is. Gentle bumps, and now it's true. Perfect. I like to establish as many large features as I can before I part this material off. It just makes for a lot of integrity in the setup to be holding on the stock size as opposed to the reduced diameter that was just previously turned. By establishing opposing features first, you can be very sure that you are not measuring over a burr. Once you've dialed it in, you know where you're at, then move on to the other side. Now the burrs are pushed to the side you previously did, and you can mic it and trust it. Center drill, drill, and then we'll move over to the lathe, part these off, and move on to the next pieces. Next piece in line are the rope cleats in the back of the chassis, the back of the carriage. And because of some difficult manual geometry on the chamfers on the outside profile of these, I'm going to do them in two pieces. I'm going to make the flange on the bottom a washer, and we'll make the eyelet section on the top a different piece. Now you've just seen me do the long stem and the thread, so I'm going to save you from that boredom, and we'll get right into the eyelet on the top. All right, this is the end feature, not the end feature, this is the feature on the end of the part that I'm going to address in a couple of minutes here. And all those little circles and lines you see are just for calculations and setup and drawing and such. Anyway, that's the part. And let's see what it looks like in the assembly mode. That is what it currently looks like right now. So I'm going to carve that last piece out of this particular cylindrical support bar that I have right now. The process that I chose to go with is going to be this right here. I'm going to put it in an indexer. I'm going to neck it down to the 090 that it's required. I'm going to put the hole in. I'm going to put the chamfer on both sides of the hole. And then I'm going to cut it off and hold it on here and do the profile. I'll be able to easily indicate it flat and pick up that hole for the rotary table work. And on the rotary table, I'll be able to access both sides easily for the final chamfers. And that's what I should come up with at the end of the day. I'll do the old shoe shine polish work on the inside and outside with some thin banded emery, and that should soften up some of the edges, make it look a little bit better. And for anybody wondering what kind of software this is Pro Engineer Wildfire 4.0. And 4.0 is a couple of releases back. This particular software is now called Creo, and it is available from PTC, Parametric Technology Corporation. This is very powerful stuff. This cut needs to terminate exactly at the face of the large diameter where the large diameter meets the small diameter. If it goes beyond that, it will cut into the small diameter and show up as a recess at assembly. It's not going to ruin anything, but for cosmetic perfection or to be visually appealing, you want that cut to end right at the face of the large diameter. We'll get pretty close here in a second, and you'll see the chip will just literally wafer right off of there with little or no resistance. By adding a little Sharpie marker to the feature, you can tell when the chamfer tool comes down and makes contact with that edge. I'm coming up with the table very slowly. As soon as I see a witness mark, I know that I'm generally close. Raise the table a little bit more and go for the final depth. If there's any chatter present here, just slow the machine down, turn it off, and let the tool coast, but raise the tool before it comes to a complete stop. That should remove any chatter. Part is currently set up on the rotary table, and we're going to start by just disconnecting this from this. Looks like a fuse, doesn't it? Looks like an electrical fuse. Glad it's not. All right, let's do it. For the roughing operation, I am going to nibble away at this, and you're going to start to see just how delicate this part is. It'll flex quite a bit under the pressure of this end mill, and this is only a 1/8 end mill. It's about a 3mm end mill. Watch it start to flex and do the diving board thing. There's a lot of movement there, so stay well away from your final dimension. That is a good piece of advice. Yes, it is. All right, good place to start. I like a climb cut finish, so I'm going to start on the other side. This is going to be a blind cut, guys. Sorry about that. All right, guys, here's a shop gem for you that you're going to put in your toolbox and take with you and say, boy, it seems so obvious. Right now, I want to even chamfer all the way around this profile. Now, I don't care if it's a key-shaped profile or a rectangular pocket. You would like a nice even chamfer on that pocket to go all the way around. The only way to do that is to treat your chamfer tool like the tool diameter that formed the last feature. So right now, I'm treating this tool like it's a 125 diameter and nothing else. By doing that, I can raise the table right there, and when I do that, the chamfer that's formed will be exactly the same on the radial features, regardless of which way they're going, so long as that tool does not move in the XY and is purely controlled on the Z. You will have consistent chamfers. Try this with a rectangular pocket sometime. Cut a 1-inch rectangular pocket with a 1/4-inch end mill, and then come down in there with a very large chamfer tool, but treat that tool like it's a 1/4-inch in diameter and watch the result. You will be very pleased. Little bit of noise on the OD, but I'm sure that'll buff out. Going to put the same tool down in the center and see if we can even up that chamfer. Not happy with that. Not even close. Actually, it's close, but not close enough. What I'm looking at right now is the land right there. The flat is much better all the way around. Pop it out, take a look. Actually, got to flip it over and chamfer it, and then we can pop it out, take a look. All said and done, this is what you can expect. Do yourself a favor if you're going to do it this way, holding on a small diameter. Be very careful about the depth of cut. This side was done with a very gentle depth of cut, and this side was done with a little more aggressive depth of cut, and you can see the noise in it, the chatter. The little railroad track marks right by my finger. That'll buff out. I'm not worried about that. All right, we've got to do the other one, and then we get a chance to put it together and see how it looks. A lot of work. Next 4 pieces I will attack will be these little clips that hold the axle to the chassis, to the carriage, whatever you guys want to call it. This is a cutaway of the side of the unit, and that's, you can see the little U-shaped piece at the bottom, how it holds the axle up against the frame. And just for illustration, I've got it colored red on the other side. One in the front, one in the back. I'm going to do these 4 at a time from a single slug and then chop them all off. So let's see how that works out. After establishing the outside dimensions of the block, I'm going to move on to doing the channel sections, and this is the little section that will grip over the wood axle and secure the axle to the chassis. Doing them all on one slug like this makes it real easy and real fast to reposition these parts in this vise for this operation. Using the 1/2-inch parallel as my gauge, I know the 1/2-inch parallel measures a 1/2 inch, and I'm going to hang all these pieces from that parallel at the final op and take a dust cut and chamfer the ends for consistency. This also makes it a lot easier on your fingers handling a big block versus handling small parts. Plus, the body of the block right here keeps you from crushing these as you machine away the channel. Additional benefit is with the parts lined up side to side, when you drill one side, you come through the other side and effectively drill two parts at the same time. I'm going to nibble away at the parts from side to side and establish a rough overall length. The little web that I'm leaving in between the parts, top and bottom, will be used for a visual alignment against the bandsaw operation that's coming up. I'll take a quick cut in a piece of phenolic, or a zero clearance throat plate, so to speak, and just make sure that that little web is over top of the saw cut. Quick and dirty visual alignment. Laying all the pieces side by side allows me to pick the shortest one and start with that one. This is a visual height, and I want to make sure that I have the shortest part as my standard. I want them all the same size, and there's nothing worse than doing something like this and getting to the last piece and realize that you've got to drop the table because you started with the wrong part. Ask me how I know. And you know you've done it, so don't smile. Immediately after the last operation, all the parts are now hanging from that 1/2 inch parallel. I took a dust cut with the fly cutter to make the end thicknesses all the same, and now the chamfer will be consistent because the top surface is consistent. If there was a difference in the end thicknesses, the chamfers would vary from part to part, and it just wouldn't be ideal. The piece of paper that you see stuck in there is for any deviations in the thicknesses, and away we go.
All right, guys, at the end of the day, this is what you're going to end up with. I'm sure there's a dozen different ways that you could do this. I chose to do it the way that I thought was going to be the most effective for holding it and drilling it. And if you didn't pick up on that, I did drill two pieces at the same time when they were back to back. So that cut down on some of the ops. There is a little bit of bowing after the fact. When you saw them off, expect them to move. No big deal. This stuff is soft. Hit it with a file. Put it back in the machine and give it a little bump. See what it looks like when you're done. They will go on here at assembly, and the stud will come through there and be held in place with one of these collared nuts. Trunnion lock blocks are in place, the cleats are in place, the nuts retaining the axles are in place. The rope cleats in the rear, I'm very pleased with how they came out. See if we can get off this lock focus here for a second, take a look at that.
It's an awful lot of work for such a small part. But, you know, when you look back on it, you're going to remember the work that went into it, and you'll be happy that you invested the time. So just one piece at a time, right? Journey of 1,000 miles conquered one step at a time kind of philosophy. Don't let the time get to you. Do what you got to do to get it done. So that's all the pieces that we just watched get done. And if you want to see a quick assembly, I'll tell you what I did do. I made brass hoops for these axles, because these axles are going to be cross-pinned. That's how they're going to be held on. So these little collars are going to be drilled as well. And the pin's going to go through the collars, through the wood, and back out the other side. I am undecided on whether or not I'm going to tree pan these wheels out and make wood inserts for them so they look like wood wheels with brass tires. Not yet. At least leave me a comment. Let me know if you think that would look good. See what I can do about making that happen. Really on the fence about it. This model's getting very close. There's a lot of real small details. I don't think that I can make a video on every component left. It would bore you to tears, and I have a steam engine that I want to do that I'm really looking forward to starting. And this is the last thing I need to do before that steam engine starts. It's a Stort D10 vertical twin. Real nice. And I've had several questions about whether or not the cannonballs fit the barrel. There's only one way to find that out, right? Let's find out. Sounds like a yes to me, guys. There you go. And thank you to everybody who left comments about the brass monkey. I had no idea what a brass monkey was until I did this. Just like everything else, you learn as you go. That's all I got for you for today. Thank you very much for tuning in. I do appreciate it. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out.